You stand at a busy crossroads, and an out-of-control truck is charging straight at you. The shrill screech of brakes cuts through the air. You close your eyes, waiting for the impact, but seconds later, you find yourself standing unharmed in place. The truck has vanished without a trace, and the pedestrians around you look puzzled by your panic. Is it an illusion, luck, or some deeper law of reality at work? What would you think if I told you that you might have just experienced quantum immortality? Quantum immortality, a concept that sounds like science fiction, is rooted in the most cutting-edge theories of quantum mechanics. It challenges the boundaries of our understanding of reality, consciousness, and death, proposing a spine-chilling possibility: your consciousness may never truly die. Instead, it constantly shifts across countless parallel universes, forever surviving in the reality where you are alive. To understand quantum immortality, we must start with one of the strangest phenomena in quantum mechanics: superposition. In the macroscopic world, the state of things is definite. A chair is a chair, a car is a car, and a person is either alive or dead. But in the quantum world, microscopic particles, such as electrons and photons, can exist in multiple states simultaneously. For example, an electron can be here and there at the same time. A photon can spin clockwise and counterclockwise simultaneously. Physicists call this state superposition, as if the particle exists in all possible states at once. In 1935, physicist Erwin Schrödinger devised a thought experiment to extend the weirdness of quantum superposition to the macroscopic world. Imagine a cat locked in a sealed box, along with a small piece of radioactive material, with a 50% chance of decaying within an hour, a Geiger counter, and a vial of poison. If the material decays, the counter triggers a mechanism to smash the poison vial, killing the cat. If it doesn't decay, the cat survives. Before opening the box to observe, the radioactive material is in a superposition of decayed and not decayed. So what about the cat? According to quantum mechanics, before observation, the cat is in a superposition of both dead and alive. Only when we open the box, that is, when the act of observation occurs, does the superposition collapse, and the cat becomes definitively dead or alive. The core confusion of this experiment is: why does observation change reality? Is unobserved reality just a chaotic cloud of probabilities? And if particles can be in superposition, could a human composed of particles also be in superposition? In 1957, a young physicist named Hugh Everett Tree proposed a revolutionary theory that completely changed our understanding of quantum superposition: the many worlds interpretation. Traditional quantum mechanics holds that observation causes a particle superposition to collapse into a definite result, e.g., the cat is dead. But Everett argued that there is no collapse at all. When observation occurs, the universe splits into multiple parallel universes, and every possible outcome actually happens in a different universe. Back to Schrödinger's cat. When you open the box, the universe does not choose whether the cat is dead or alive. Instead, it splits into two universes, one where the cat is dead, and another where the cat is alive. Both universes are equally real. The only difference is that you can only perceive one of them. Everett's theory was ignored, even mocked, by the scientific community at the time because it was too bizarre. But with the development of quantum mechanics, the many worlds interpretation has gradually become one of the mainstream theories. Today, many physicists believe it may be the simplest explanation for quantum superposition. Reality does not choose one path, but takes all paths at once. You just can only see the one under your feet. If the many worlds interpretation is true, a terrifying follows: quantum immortality. In 1998, physicist Max Tegmark designed a quantum suicide experiment to directly test this possibility. The experimental setup is simple: a gun controlled by a quantum event, such as the decay of a radioactive atom. Each time the trigger is pulled, there is a 50% chance the quantum event will fire the gun, you die, and a 50% chance the gun will misfire, you survive. From an observer's perspective, at the moment you pull the trigger, the universe splits into two, one where you die, and one where you survive. As the experiment is repeated, say, 10 times, the observer will see you die in most universes, with a survival probability of 1/2. 10 is almost equal to 0.1%, eventually resulting in certain death. from the participant's perspective, but from your own viewpoint, things are completely different. Each time you pull the trigger, you will only experience the universe where the gun misfires. Because death is a state you can never perceive, you can never experience your own death, only survival. Tegmark's conclusion is, from a first-person perspective, you will live forever. No matter how many times the experiment is repeated, you will always find yourself in the universe where the gun misfires. To others, you may have long since died, but in your consciousness, you live forever. If we are constantly shifting between parallel universes, why have we never felt it? Why doesn't the world look completely different when we wake up? The answer lies in the phenomenon of quantum decoherence. Quantum superposition only exists in isolated systems, that is, when particles do not interact with the outside world, such as air molecules or photons. But macroscopic objects, like humans, cats, or the Earth, are composed of trillions upon trillions of particles, which are constantly interacting with their surroundings, such as the air you breathe or the light you see. This interaction causes superposition to decohere rapidly, just as water waves break when they hit a rock. The probability cloud of superposition collapses into a definite reality in an instant. An analogy for decoherence: imagine tuning a radio, where different frequencies correspond to different stations, parallel universes. When you tune to a certain frequency, reality, the sounds of other frequencies are filtered out. That's the role of decoherence. It acts like a reality firewall, preventing you from perceiving other parallel universes and keeping you stable in your current frequency. This also explains why we can't remember date realities. When you die in Universe A, your consciousness has already shifted to Universe B, where you survive, and decoherence erases all memory traces of Universe A. You will only think, that was a close call, I almost died, without knowing that in another universe, you have died once. Another enigma of quantum mechanics, the observer effect, adds an even weirder dimension to quantum immortality. The act of observation itself changes quantum outcomes. In the double-slit experiment, a single electron is fired at a screen through two slits. If no one observes it, the electron behaves like a wave, passing through both slits simultaneously and creating an interference pattern on the screen. But if someone observes it, e.g., using an instrument to record the electron's path, the electron immediately becomes a particle, passing through only one slit, and the interference pattern disappears. Conclusion: the mere act of observing changes the state of particles. When unobserved, particles are probability waves. When observed, they become definite particles. If observation can change particles, can consciousness actively choose reality? Some physicists, such as Roger Penrose, and philosophers have suggested that consciousness may be a quantum process. When you observe, your consciousness actively locks onto the reality where you survive. For example, in a life or death situation, like a car accident or illness, your consciousness may act like the observer in the double-slit experiment, choosing the version of reality where you survive through the act of observation. This is not luck, but the result of interaction between consciousness and the quantum world. Have you ever had a moment where you were certain you were going to die, but survived against all odds?